Good morning friends, my name is Akshay Elmave. I welcome to all of you to my YouTube channel Math State Board Education. So in this video we are going to learn the mathematics part 1 of the standard 10. So in this video we are going to learn the first chapter of mathematics part 1. So linear equation in two variables. So let's see. So in this lecture we are going to see what is the linear equation in two variables. Okay, so we are going to study the methods of solving the linear equation in two variables. First method is graphical method and second method is Cramer's method. Then we are going to see the equation that can be transformed in linear equation in two variables. Then at last we are going to see the application of simultaneous equation. So guys, just recall, you have learned in the 9th standard, so what is the linear equation in two variables? So linear equation is an equation which contains two variables and the degree of each term containing variable is 1 is called as a linear equation in two variables. So let us understand this from one example. So when we call the equation as a linear equation in two variables, so we see the one example, x plus y is equal to 8. So in this equation, when we call this equation as a linear equation in two variables, so there is a criteria. The criteria is that each term containing the variables has a degree 1. So here variables are x and y, and the degree of this variable in the each term is 1, that is the power of x. Here is 1, here is 1. So if the degree of the variables in each term is 1, then that equation is called as the linear equation in two variables. So let's see what is next. So ax plus by plus c is equal to 0 is the general form of a linear equation in two variables. So how we can write the general form of any linear equation in two variables? So for that we consider the example. So if we write equation as a x plus y is equal to 8, then how can we write the general form of this linear equation in two variables? To write any linear equation in two variables in the general form, the criteria is that you have to shift all the terms to the left side of the equal sign. Then you have to write the 0 at the right side of the equal sign. So let's see how this equation reduced to general form. So x plus y minus 8 is equal to 0 is the general form of this linear equation. Is the general form of this is the general form. Okay, so you understand. So let's see next. So So ax plus by plus c is equal to 0 is the general form of a linear equation in two variables. So here a, b and c are real numbers and a and b are not equal to 0 at the same time. Okay guys, so from this equation we can understand that the ax plus by plus c is equal to 0 in this equation. At the same time we cannot write both a and b equals to 0. Okay, so at one time a can become 0 and another time b can become 0. So they give the example here, so they how to convert the any equation into general form. So here the 3x minus 4y plus 12 is equal to 0 is the general form of the equation 3x is equal to 4y minus 12. So as we discussed, the criteria to convert the any linear equation to the general form, that is to shift all the terms to the left side of the equal sign and then write the 0 at the right hand side of the equal sign. So how we reduce this? So we shift 4y and 12 to the left side of equal sign, that is the equation becomes 3x minus 4y plus 12 is equal to, and we write 0 at the right hand side of the equal sign. So next is the complete the following tables. So as we discussed earlier, how we identified the any equation as a linear equation in two variables. So we have to identify these equations are the linear equations in two variables or not. So in first example they given yes, it is the linear equation in two variables. So how can we identify these? So we have discussed it earlier, so once again we discuss it. So here the each term is 4m plus 3n and the variables are m and n. So you can write variables as letter from a to z, any letter from the a to z. Okay, so here in the first term 4m and second term 3n, the variables are m and n and the power of the variables is 1, that is the degree of the variable is 1. So we can say this is a linear equation in two variables. So likewise we see the next example. In the second example, the first term has the variable 3x square. In this the power of the variable is 2, that is degree is 2. So we can say this is not a linear equation in two variable. So we make a cross here to show this equation is not a linear equation in two variables. So let's see the next example. In this example, the root 2x minus root 5y is equal to 16. Here the root is only for the coefficient, not for the variable. So we here the power of the variables both the variables in both the terms are 1. So we can say this as a linear equation. Okay, so let's see next example. In this equation 0x plus 6y minus 3 is equal to 0. The power of both the variables in both terms is 1. So we can say this as a linear equation in two variables. So guys, let's see here we write the 0x plus 6y, that is we make the ax, that is a is equal to 0. At the same time we have the value of the b non-zero. So this is about that we have read above. So in the next example, the 0.3x plus 0y minus 36 is equal to 0. Both the terms have the power of the variables 1. So we can say this is also the linear equation in two variables. So let's see the example number 6. So this equation we can reduce this equation in the simple form by making the uh, below term same. Okay, so below term same. So how can we reduce this equation to simple form? So we can multiply the first term by y, so we get 4y, and we can multiply the second term by x, 5x, and we get the at the below xy. Okay, and we can write the right side same. So we can shift this xy to the right side in the multiplications. Here is the xy is at the below, that is at the at the division, so we can shift this into the right side as a multiplier. Okay, here is it is the divider, so we can shift it as a multiplier on the right side. So how can we shift this? So we get we get 4y plus 5x is equal to 4xy. 4xy. So look the each term in the equation. So here the power of variable is 1, power of variable 1. Here is also the power of variable, that is degree of variable is 1, but in the last term there is a 2 variable in one term or in this term. So we can write the degree of this term as a sum of the power of each variable, that is it is equal to 2. So we can say this equation is a not linear equation in two variables. So likewise here is also the term 4xy, so we can say this equation is also not a linear equation in two variables. Okay, okay, so this is not a linear equation in two variables. This is also not a linear equation in two variables. So we have understand this concept of how to identify the linear equation in two variables. Okay guys, so let's see what is the next. So here here the next is simultaneous linear equation. So what is the simultaneous linear equation? So when we think about the two linear equation in two variables at the same time, they are called as a simultaneous equation. So let's understand this concept from the example. So if we took the two equations x plus y is equal to 4 and x minus y is equal to 4, and we consider this equation at the same time, then we call these equations as a simultaneous linear equations. Okay guys, so this is the simple concept of the simultaneous linear equation. So let's see how to solve the simultaneous simultaneous linear equations. Okay, so in the last standard we have seen the two methods to solve the simultaneous linear equation. The first method is elimination method and the second method is the substitution method. So just for recalling you, I will solve this example by the both the method. Okay, so let's solve this example by first by elimination method and then by substitution method. Okay, so what is example? Example is 5x minus 3y is equal to 8. This is equation number 1, and equation number second is 5x minus 3y is equal to 8, and equation second is 3x plus y is equal to 2. So 3x plus y is equal to 2. So this is equation number 2. So in the first method, the method of the eliminations, what we do, so we see the both the variables, and we are trying to eliminate the one variable from the both the equation. Okay, so to eliminate the one variable, we we have or we want the same coefficient for that variable. So if we look the term the variable y, so in the equation number 1 the variable y has a coefficient -3, and in the second equation the variable y has a coefficient 1. So if we want to eliminate the y, we have to convert the coefficient in the second equation to equal to 3. So we get -3 and 3. So we can easily eliminate this variable y by adding the both equations. So to convert the second variable y to 3y in the second equation, we multiply the second equation by 3 on the both the side of the equation. So let's do the first step. So let's do the first step. What is the first step? First step is equation, you can write the multiply the equation 2 by 3. So I will write equation 2 multiply by 3. So we get 9x plus 3y is equal to 6. We can say this as equation number 3. So in the next step we can easily solve the equation we can easily solve the equation 1 and equation 3 by adding the equation 1 and 3. So next step is equation 1 plus equation 3. Okay, so we write position 1. Equation 1 is 5x minus 3y is equal to 8. And what is equation 3? Equation 3 is 9x plus 3y is equal to 6. So we add this equation. So we get, if we add this equation, we get 5, we get 14, 5 plus 9, 14x plus here minus 3y plus 3y gets cancelled. That is, we have eliminated the variable y. So here we can write 0y is equal to 8 plus 6 is 14. Okay, so from this we get x is equal to 14 divided by 14, that is x is equal to 1. Okay, so we get the value for the variable x. So by putting this value of the variable x, by putting this value of the variable x into the equation 1 or any equation from the equation 3 of the above, we get the value for the variable y. So let's put this value, put in equation 1, put in equation 1, we get value of the y. So let's solve. So what is equation 1? Equation 1 is 5x minus 3y is equal to 8. So value of the x is 1, so here we get 5 into 1 minus 3y is equal to 8. So here minus 3y, by solving this, minus 3y is equal to 8 minus 5. So we get minus 3y is equal to 3. So value of y is 3 divided by minus 3 minus 1. So we have solved this simultaneous equation, and the solution of this simultaneous equation is x is equal to 1 and y is equal to minus 1. This is your final answer by the method of elimination. So we have solved this simultaneous equation by the method of elimination. So again we will solve this equation by the method of substitution. Okay, so let's see how to solve the same example with the method of the substitution. So we take the same example, 5x minus 3y is equal to 8. This is equation 1. And second equation is 3x plus y is equal to 2. Second equation 3x plus y is equal to 2. Equation 2. So in the method of substitution, what we have to do? So in this method we are trying to eliminate the or we are trying to write the variable, one of the variable in the equation in terms of the other variable. So here it is easy to write the y variables in the second equation in terms of the x variable, and by writing this we put this value of the y into the first equation to get the equation in terms of the variable x. So we can easily solve that equation to obtain the value of x variable, and after getting the value of x variable we put this into the our next equation, that is as we write the value in terms of the x. So by putting the value of x we can get the value of y. So let's see how we write this. So first step is to write this y in terms of the x in the second equation. So we can write y is equal to 2 minus 3x. So this is our equation number 3. So let's see how we solve. So next step is put this value of y in equation, put this value of y in equation 1. Okay, so what is equation 1? equation 1. So what is equation 1? 5x minus 3y is equal to 8. Okay, so we put the value of y in this, so we get 5x minus 3 into in bracket y's value is 2 minus 3x, okay, is equal to 8. So by solving this we get the value of variable x. So how we get value of variable x? So let's solve this equation. So 5x minus multiply by 3 into in bracket, so we get 3 into 2 6 minus 3 into 3 is 9x, okay, is equal to 8. Okay, so in this step we will going to take the terms from the bracket out. So let's see what will happen after taking the term out from the bracket. So we get 5x minus we multiply this minus to turn inside the bracket, so we get minus 6. So by solving this bracket we get minus 6, and minus into minus multiplication we get plus 9x is equal to 8. Okay, so by solving this we get 9 plus 5x is equal to 14x, and we shift this minus 6 to the right side of the equal sign, so we get 8 plus 6 is equal to 14. Okay, so we get the value of x is equal to 14 by 14, that is equal to 1. Okay, so to solve the value of y, or to get the value of variable y, we will put this value of x is equal to 1 in our third equation. Okay, so x is equal to 1, put in equation 3. So we get value of y. So y is equal to, what is third equation number? Third, y is equal to sorry, y is equal to 2 minus 3x. Okay, so y is equal to 2 minus 3x. So we put x is equal to 1, so we get value of y. So y is equal to 2 minus 3 into value of x is 1, so we get y is equal to 2 minus 3, so y is equal to minus 1. 2 minus 3 is minus 1. Okay, so from this method of substitution we also get the same value as we get by the elimination method. So solution of this equation by the substitution method is x is equal to 1 and y is equal to minus 1. So this is the solution of the given equation. Okay, so we have seen both the method to solve the simultaneous equation. Okay, so this is about the today's video. So we will see in the next video the graphical method for the solution of the simultaneous linear equation. Okay, and we will see the 1 or 2 example from the question set on this method that we discussed today. So goodbye friends, please like, share my video and subscribe my YouTube channel. Thank you friends for watching my video.